Today's standard is 8.EE.7a, solve linear equations in one variable. And our essential statement is I can solve two-step equations. So what I did was I took two lessons and I'm going to be making one video on both of these lessons. They're both on two-step equations, but the first part is going to be mostly positive numbers, and the second part is going to involve negative numbers in our equations. So, what is our goal when we solve two-step equations? Well, our goal is to solve for the unknown value, which means you get the variable by itself. So you will have a variable, you will have an equal sign in an equation, and the whole point is to get the variable by itself, to solve for, let's say, x. X equals a number. So what we did in 7th grade was we had one-step equations, something like x plus 4 equals 7, solve for x, and we're just building upon that and moving on to two-step equations. So what I have done for you today was I wrote out the steps that I believe are helpful when solving equations. Yes, you need to write these down. Yes, these are important. Yes, you will need to know these by the time we are done with this lesson. And we use them so often that you will probably have them memorized by the time we are done with this unit. So I will go ahead and use those steps. If you need to pause the video to write them down, feel free to do so, but I will use these steps to solve our two-step equation for x plus 5 is equal to 13. So our first step, draw a line down the equal sign. That is always our first step when working with equations. Our second step says find the side with the variable. So it can be on either side, but in this case, our variable is over here on the left-hand side. The next step, find the number not attached to the variable. That would be positive 5. Then we have perform the opposite operation. So the opposite of plus 5 is minus 5. Remember, opposite operations, addition and subtraction are opposites, okay? Multiplication and division are opposites. You will need to know that. Next step, number 5, whatever you do to one side, you must do the same thing to the other. So I have to subtract 5 right here. Now we solve, okay? 5 minus 5 is 0, so I can get rid of that. That's why I can cross it out, because 5 minus 5 is 0. And 13 minus 5 is 8. Then I bring down what I did not use, which is 4x is equal to 8. And now this is just a one-step equation. You can repeat the steps again if you need to do so. So you draw a line down the equal sign. Excuse me, you find the side with the variable, and now you find the number attached to the variable and perform the opposite operation. So what you need to know is that when a number and a letter, a variable, are right next to each other, that is multiplication. When a number and a variable are right next to each other, that is multiplication. So the opposite of multiplication is, in fact, division. So I'm going to go ahead and divide by 4. But whatever I do to one side, I must do the same thing to the other. Now, 4 over 4 is 1, so that technically goes away. We do not write 1x, we just leave it as x. And 8 divided by 4 is 2. Remember, this means division now. Okay, this means division. So in our example, x is equal to 2. Now, one thing I wanted to tell you, how do you know if what you got was a correct answer? Well, it's pretty simple to find that out. You take what your answer is, in this case 2, and then you plug it back in. Okay, so 4 times 2 is 8, plus 5 is indeed 13. So that's how you know that that answer is correct. All right, now what we're going to do is we're going to do a couple more examples for this lesson today. So you see all the different ways these equations can be written. All right. Oh, another thing that I have is people are like, well, how come there's like way more than 2 steps when we're solving two-step equations? Well, these steps I write out because I literally break down everything. What the two-step equation means is it's two operational steps. For example, here we subtracted 5 and here we divided by 4. That was 2 steps. So it took 2 mathematical steps to solve for our unknown value. Okay, so I know that's a point of confusion. All right, I'm gonna try to keep the steps up so that you can refer to the steps when we're solving these equations. So we have 4 plus 2a is equal to 12. Let's go ahead and use our steps. Draw a line down the equal sign. Find the side with the variable. Find the number not attached to the variable, 4, and perform the opposite operation. The opposite of positive 4 is minus 4. Whatever you do to one side, you must do the same thing to the other side of the equal sign. And then you solve. 4 minus 4 is 0. 12 minus 4 is again 8. And then we bring down what we did not use, 2a. And then you repeat the steps. Draw a line. Find the side with the variable. Perform the opposite operation. When a number and a letter are right next to each other, that means multiplication. So we would divide. Whatever we do to one side, we must do the same thing to the other. 2 divided by 2 is 1, so that cancels out. And we have a is equal to 8 divided by 2, which is 4. All right, next example. Yes, I know this one looks a little bit different, but the steps do not change. Draw a line down the equal sign. Find the side with the variable. Now it's on the other side. Find the number not attached to the variable and perform the opposite operation. So I'm going to add 5. Whatever I do to one side, I must do the same thing to the other. It's all balance, okay? We can't just keep adding or subtracting or multiplying or dividing all on one side. We have to balance out our equations. Negative 5 plus 5 is 0, so that goes away. 3 plus 5 is again 8. 8 is my favorite number, so maybe that's why I kept using it. And then we bring down what we did not use, k over 3. Now remember, k over 3. This means division, okay? Fractions mean divide. So k divided by 3. What is the opposite of division? Well, it's in fact multiplication. So if we multiply by 3, we have to do the same thing to the other side. This goes away. Now people are like, wait, that doesn't make sense. Why does this go away? Okay, so take a look at how I break this down. If you have k over 3 times 3, this is really 3 over 1. So when we multiply that out, we get 3k over 3, and then it just goes away. Okay, that's why we can cancel that out without doing all of this extra work. So we have k left, and 3 times 8 is 24, so k is equal to 24. All right. So I'm going to go ahead and move on to the next page. Now these are the notes from technically the next day, but because it's the same standard and essential statement, I'm just going to go ahead and do these 3 examples that I have lined up over here. Again, the steps do not change. That's why I wrote, remember the steps, they're on the previous page. You will need to know the steps for any equation that we do ever, whether it's 1-step, 2-step, multi-step, has a bunch of stuff in it. Okay, the steps never change. So let's go ahead and get started. Negative 2x plus 6 is equal to 8. Draw a line down the equal sign. Find the side with the variable. Okay, find the number not attached to the variable, which is this one, positive 6, and perform the opposite operation. So the opposite of positive 6 is negative 6. Whatever you do to one side, you must do the same thing to the other. So 6 minus 6 is 0, that goes away. 8 minus 6 is 2. Bring down what you did not use, which is negative 2x is equal to 2. Follow the steps, draw a line, find the side with the variable. Now find the number attached to the variable and perform the opposite operation. So I'm going to go ahead and divide by negative 2. Whatever I do to one side, I must do the same thing to the other. So negative 2 divided by negative 2 is 1, so that goes away. And I have x is equal to 2 divided by negative 2, which is negative 1. Again, as you notice, steps don't change. Now we just have negative numbers in our equations, so the operations become slightly harder, okay? Slightly harder. All right. -3 is equal to 5 minus m. Draw a line down the equal sign. Find the side with the variable. Find the number not attached to the variable and perform the opposite operation. Now, here's a common misconception. You think because this negative is right after the 5, you think you're going to add 5. But no, you have to take the sign in front of the 5. Since there is no sign in front of the 5, it means it's a positive 5. So the opposite of positive 5 is actually negative 5. And then whatever you do to one side, you must do the same thing to the other. So 5 minus 5 is 0. That goes away. And again, -3 minus 5. Now, if we were in class, I would tell you to refer to the number line that we have above the whiteboard. Here I have a number line for you. Now, remember, when you subtract, that means you go to the left on the number line. You would start at -3, okay, and it's -5, so you'd go left 5. 1, 2, 3, 4, 5, you would land at -8. Now, one thing I wanted to tell you is if you have trouble with subtracting integers or even adding integers, please draw out or print out or do something and get yourself a number line, okay? It is helpful. Addition means you go right, subtraction means you go left on the number line, okay? So -3 minus 5 is indeed -8. It is not 2, it is not -2, it is -8. And then you bring down what you did not use, which is -m. Now, a lot of people will be like, oh, woohoo, I'm done. I got the variable by itself. No, you didn't. The variable still has a negative sign next to it. So technically, it's not by itself yet. This -m really means we have a -1m. And we still need to get rid of that -1 to indeed get the variable by itself. And again, the opposite of multiplication is division, so I would divide by -1. But whatever I do to one side, I must do the same thing to the other. So then this goes away, and we get m is equal to -8 divided by -1, which is +8, because a negative divided by a negative is a positive. So m equals 8. And our last example, 0 equals b over -5 plus 11. Now, in class, I have students say, oh, you're actually making me think. I actually have to do work. You guys, you have to do work for all of these, okay? Yeah, sometimes you can do them in your head, but most of the time you need to write them out. Even I can't do them in my head a lot of the times. So that's why I have the steps written out so that you can refer back to the steps when you need to do so. So let's go ahead and start. Draw a line down the equal sign. Find the side with the variable. Right-hand side. Find the number not attached to the variable, +11, and perform the opposite operation, which is -11. Whatever you do to one side, you must do the same thing to the other. So 11 minus 11 is 0, and 0 minus 11 is -11. Okay, again, if you had a number line, you would start, your starting point would be your first number, which is 0, and -11 means you go left 11, and you would go left, and our number line kind of ends at -10, but it would be right here at -11. And you bring down what you did not use, which is b over -5, and this means division, so the opposite of division is, in fact, multiplication, so I'd multiply by the number, which is -5, and then whatever I do to one side, I must do the same thing to the other. So this goes away, and you can refer back to my previous example about why that is. And we have b is equal to -5 times -11 is +55, because a negative times a negative is, in fact, a positive, so b is equal to 55. And those are our examples. I know there was a lot of examples. I tried to cram 2 lessons in one, but that's okay. If at any point you need to review it or go back and look at it, you are free to do so. And if you have any questions, please let me know.